Hello everybody and welcome back to the multiplayer project, where we're going to do a lot of work today on actually largely refactoring. Like, this is going to work mostly the same way, but I've come up with a better way to do a lot of what we're doing. So we're going to just hop in here. We don't need tileset open. We're just going to hop into tile.cs here, and we're going to do a tiny bit of work here. We are no longer going to need these fields. We're just going to get rid of those, and we're going to do a public tile data. Excellent. Now, of course, tile data doesn't exist. Let's go ahead and make one, shall we? So we're just going to go into our tile sets here, and we're going to add in a new item. And actually, I'm going to do this in Unity. I prefer to do it this way. So we're going to go into tile sets here, and we are going to create a new C# script, and we're going to call this tile data. Wonderful. And yes, we created a lot of issues. We'll be solving those. So we're going to get rid of everything in here. This is not going to be a mono behavior. We honestly don't need to use anything. This is going to be a data class, and we may as well, I think, move terrain shape into tile data. And so we shall. Wonderful. And then we are going to actually just get rid of tile type. I don't think we need that anymore. Okay, so inside of our tile data class here, all we're going to have is a few things. Public map region. We're going to have a public terrain shape. We're going to have a public int height. We're going to have a public int x and y. And we are going... Public does not have an n in it. Okay, there we go. We're going to have a public tile data. So a reference to our north, south, east, west, northeast, northwest, southeast, and I don't know why I typed out and, southwest. Okay, so that's all of the data that we're going to have in our... Oh no, I missed one. We're going to have one more. Public int, this will be our rotation. Wonderful. Okay, so we shouldn't need anything else in tile at this point. This is now correctly set up. We can close that. And honestly, we can close tile data as well. We don't need anything else here. Now, in our map, we're going to pretty heavily refactor this. So first things first, we're going to get rid of these two fields. What were these? The terrain shape direction and the vector3 tile rotation. Those are no longer necessary because those are going to be contained in our tile data class. Of course, this tile.tiletype, that's going to have to change. We've got 55 errors here. We're going to tackle those one at a time. For right now, we're just going to hop down to generate map. Let's see, generate map is here. And inside of generate map, we're going to add ourselves in a new array here. This will be an array of tile data, a 2D array, tile data, and we will do generate terrain data. Excellent. Now we're going to come down here to just below get tile position. And realistically, I mean, we can fix this. This would now be tile.tiledata. This would then be terrain shape. Equals, and then this would be terrain shape dot flat. Since that is a thing, there we go. So there's our get tile position done. And then in get tile here, this is going to get very heavily changed. And right here, we're going to go ahead and put in private. This will return a tile data 2D array, generate terrain data, and then that'll take in our 2D array of heights, so map heights. Wonderful. So now tile data, 2D array, terrain data. I called it terrain data. Yeah, let's call it terrain data. And that's going to be equivalent to a new tile data of size map size X and map size Y. Wonderful. Now we're going to pre-declare some variables here, just because I don't want to declare them in the loop. So we're going to do int west. I'm going to do west height, east height, north height, south height, and then also northeast height, northwest height, southeast height, and also southwest height. That's heat, not height. Excellent. And now we'll simply do our loop here. So for int x equals 0, x is less than map size x, x++. Then inside of that, our second loop for int y equals 0, y is less than map size y, y++. For now, we'll leave that empty, and apparently I removed a curly brace here. There we go, problem solved. And then we will simply return terrain data. Nope, not terrain, terrain data, like that. Now the reason I didn't call this class terrain data is because there's a Unity class called that. So we'll just call it tile data. Wonderful. Okay, so we're going to grab a lot of things out of our get tile and put it into generate terrain data here. Excellent. So the first thing we're going to do is we're going to grab all of these, and we're just going to do that right inside of here. Excellent. And we don't want to redeclare these integers, of course. So we'll just do that. Okay. And now we're actually going to grab all of these as well. Let's go ahead and grab the diagonals here. I don't think there's too much reason to not do this right now. So we'll say, okay, fine. We'll get diagonals. Wonderful. So now let's create ourselves a new variable here. Or rather, let's create ourselves a new tile data in the array. Terrain data xy is equal to new tile data, and we'll start that by assigning in our region. So our region equals get region from coordinates. Our coordinates are xy. Not a semicolon. I always do this. It's a comma. Height is equivalent to map heights xy. X is equivalent to x, and y is equivalent to y. We could also set our... Actually, no, we can't set anything else here. We cannot set our rotation or our direction at this time. Okay, fantastic. Now, in terrain data, we no longer need these because we're not doing that anymore. And then we're going to grab all of these areas out of here. All of these regions. We're just going to cut those, and we're going to paste those up here. And I'm just going to, for right now, minimize those. And yes, there are a million errors in them. We will handle those in a little bit. Okay, our peninsulas, our corridors, and our straight shapes. Wonderful. Okay, so at this point, we now have this set up. So in theory, there are no errors here. In reality, there are a million errors here. I'm aware of this. We're going to hop down to get tile, and we're just going to refactor that really quickly here. So in our get tile, we don't even need to grab our region anymore, and we don't need this declaration. Like, we don't need any of this. We're going to completely rewrite from this point, get tile. So all we need here is simply switch terrain shapes, or actually I'll call this terrain data xy, which of course we don't have. So we'll go ahead and change this from int map heights to terrain shape 2D array, and that would be terrain data. Excellent. So switch terrain, that is not how you spell. Terrain data, no, data xy. I don't want to use the Unity stuff. There we go. In reality, we should maybe put this into a different namespace, but I'm too lazy. We'll put that into a to-do. Namespaces. Okay, there we go. Wonderful. Okay, so for this, all we're going to do is a very simple evaluation. So we're going to do our cases first. Case terrain shape dot flat, case terrain shape dot straight, case terrain shape dot corner inside, case terrain shape dot corner outside, case terrain shape dot corridor, case terrain shape dot peninsula, case terrain shape dot island, case terrain shape dot diagonal, case terrain shape dot diagonal to normal, and default we will debug.log error, get tile, actually we'll do map.get tile, unknown terrain shape. In this case, we'll just return no. Okay, so that actually compiles as is, but we're going to be changing this. So for flat, we need to check, or actually for all of these, we need to check if it is flooded. So let's actually get ourselves a handy little variable up here. We'll do a bool flooded equals, and this will be terrain data xy dot region. Oh, this is a terrain shape. This needs to be a terrain data, except it's a tile data. I've managed to confuse myself. Wonderful. So this is a tile data, and we need to do .region.flooded. And the only reason we're declaring this Boolean variable here is so that we don't have to do nearly as much typing down here. So we'll do return flooded, and then if that is true, we will return tileset.waterTile. Otherwise, we will return tileset.baseTile. Excellent. Okay, why is this not compiling? This is a terrain. This returns a tile, yeah. Cannot implicitly convert terrain shape to tile data. Oh, of course. It's because we need to be doing, instead of switching terrain data XY, we need to switch terrain data XY dot terrain shape. Wonderful. I've managed to confuse myself even further. But luckily I figured it out. So we need to, down here for straight, return flooded. We'll evaluate that. And if it is flooded, then we'll do tileset dot shore tiles. Shore tiles, here we go. Dot get random item of type tile, and we'll pass in the random. Otherwise, we will do tileset dot cliff tiles, which will be the one all the way at the bottom. Dot get random item tile of type random. Excellent. So this just makes get tile so much cleaner and so much easier to handle. This refactoring was pretty important. Like, even this is still going to be a little bit messy up here, but we should, in theory, be able to handle it. So that'll be excellent. For now, we will do return flooded. And then this is a corner inside, so tileset.shore corner inside tiles dot get random item of type tile. And we'll pass in our random generator. And then tileset.cliff tiles. This will be, of course, cliff corner inside tiles. Dot get random item of type tile. And we'll pass in random. Excellent. Okay, and now we'll just need to do this a couple more times. For corner outside, return flooded. Evaluate that. Tileset.shore corner outside tiles dot get random item of type tile, and we'll pass in our random. And we'll then also do tileset. Nope, tileset dot. This will be cliff corner. This will be outside tiles. Dot get random item of type tile. Random. Wonderful. For corridors, we will return flooded, and then we'll evaluate that, and tileset dot shore corridor tiles, which we don't really, strictly speaking, have right now. Dot get random item of type tile. Random. And then we will otherwise do tileset dot cliff corridor tiles dot get random item of type tile, and we'll pass in our random generator. Fantastic. Only 4 more to go. So for peninsula, we will return flooded, not float, flooded tileset dot shore peninsula tiles dot get random item tile of type random. And then if that's not the one we're returning, otherwise we want to, of course, return tileset dot cliff peninsula tiles dot get random item of type tile, and we'll pass in our random. Wonderful. Next up, our terrain shape dot island, return flooded evaluation. If true, tileset dot, this will be shore island tiles dot get random item of type tile, pass in our random generator. Otherwise, tileset dot cliff peninsula tiles. No, this is shore island tiles, so this would be cliff island tiles. What am I talking about? I was reading the above line. Dot get random item of type tile. Random. Wonderful. 2 more to go. We'll return flooded tileset dot shore diagonal tiles dot get random item of type tile. Random. Otherwise, tileset dot cliff diagonal tiles dot get random item of type tile. Random. Wonderful. And then for diagonal to normal, we will do return flooded tileset. That's not how you spell. Tileset dot shore diagonal to normal tiles dot get random item of type tile. Random. Random. There we go. Otherwise, tileset dot cliff diagonal to normal tiles dot get random item of type tile. Random. I still can't type. Okay. Now, obviously, these lists don't exist. So let's pop open our tile set here. And we'll do public list tile cliff diagonal to normal tiles equals new list of type tile. And then down here, public list tile shore diagonal to normal tiles equals new list of type tile. Wonderful. So those now exist. Okay, so let's hop back over here, and that is our get tile, at this point done, although we may have to extend it with more terrain shapes later on. We almost certainly will. I did notice a corridor corner that we're going to need, and maybe a few other things. Okay, so now we'll work on fixing some of these errors, and many of these are in here. But first, let's go ahead and implement in our generate terrain data here. Let's implement our diagonals, since we made those last episode. So we'll do a region diagonals here. We'll end that region. Wonderful. So, if one... Does that make sense? If one from 2 axes are the same as our height. If 2 opposite tiles are the same as our height diagonally, and another is greater than or equal to our height, and the other is less than our height. This is diagonal. Okay, that makes a little bit more sense. Fix that typo. Wonderful. So, if our northeast height is equivalent to our southwest height, and our northeast height is equivalent to our map height at xy, then we're top left to bottom, or no, we're top right. Yeah, we're top right to bottom left. But which way are we facing? So if our northwest height is greater than or equal to our map heights xy, and our southeast height is less than our map heights xy. In this case, I deleted a curly brace. There we go. In this case, our terrain data xy dot terrain shape is equivalent to terrain shape dot diagonal, and our terrain data xy dot rotation is equivalent to 180. We now know what direction we're facing. Else, if our southeast height is greater than or equal to our map height, so map heights xy, and our northwest height is less than our map heights at xy. In this case, terrain data xy dot terrain shape is still equal to terrain shape dot diagonal, and terrain data xy dot rotation equals 0. This should not be a floating point number. This is an integer. Wonderful. And you might ask, why don't we set the terrain shape out here and only set it once, rather than setting it like this? That's because I only want it to set anything if both of these if statements are true. If this is true and this or this is another way to say this. So we would do an and this right here. So we could just do, say, this or this. And I'm not going to do it that way because it's very long this way. We're going to keep doing it this way. It's a little bit more typing, but that's fine. So we're going to do an else if our northwest height is equivalent to our southeast height, and our southeast height is equivalent to our map heights xy. This is just the opposite direction here, so we're top left to bottom right, but which way are we facing? So we're going to do an if statement here, and this is if northeast height is greater than or equal to map heights xy, and, there we go, and southwest height is less than map heights xy. In this case, our terrain data xy dot terrain shape is still equal to terrain shape dot diagonal, and our terrain data xy dot rotation is equal to 270f. Not f. It's an integer now. I didn't change that in the other project. I'm going to do that every time, probably. And then we'll do an else if down here. This will be northwest height is equivalent to southeast height. Or no, what am I doing? This needs to be if southwest height is equivalent to, greater than or equal to, rather, our map heights xy, and our northeast height is less than our map heights xy. In this case, our terrain data xy. Terrain shape is still equal to terrain shape.diagonal, And our terrain data xy dot rotation is equivalent to 90. And I'm not making it a floating point. Ha! Take that, me. Fantastic. Okay, so there's our diagonals done. We need to change all of these, though, because we have syntax errors in all of them. Absolutely all of them. Let's just start going through our syntax errors, and this refactoring was always going to generate a lot of these. So tile data equals generate terrain data. We need to pass in our map heights here, of course. So we'll pass in map heights. Wonderful. Next one. We cannot convert from int to tile data. Right, so we, instead of passing in map heights here, we pass in tile data. Wonderful. And instead of quaternion.Euler tile rotation here, we instead need to pass in a quaternion.Euler. This will be a new vector 3, and we're going to pass in 270. We're going to pass in, let's see here, this would be tile.tile data, which we're not currently assigning, dot rotation. Excellent. And in get tile, let's... This is just the instantiation. Okay. So our tile data equals, this will be tile data at position ij. Excellent. So instead of doing it this way, we'll just do data.rotation. And then we'll go ahead and assign map ij dot tile data equal to data. Wonderful. Okay, so that's now assigned. And let's continue going down this list. The name direction does not exist. Yes, that is because, of course, we need to set all of these to be like we did down in the diagonals with the terrain data dot terrain shape. I'm just going to copy this because we're going to need it a lot. Okay, so we'll just get rid of this. And actually, I'm just going to copy this section. And we're just going to go through and replace all of these directions with that. Wonderful. And of course, we're also going to need to do the same thing with the tile rotations. That does not need to have those spaces there. We'll get rid of those. And this is just a more robust way of doing this. We can take another pass if we need to. We can access our data as necessary. All these things. Okay, so we'll grab terrain data xy.rotation, and we'll go through and replace all of these tile rotations here with that. Wonderful. There we go. A couple more to go. We have gotten through the majority of these errors. So we have 19 errors remaining. Oh. .y. Okay. Yep, those should not be .y. That should just be rotation. I forgot that it doesn't select that entire section. So we'll just have to get rid of these .ys. And of course we'll have to get rid of the floating point numbers as well. Because there is not a direct conversion there. We could use an explicit conversion, but what's the point in doing that? Okay. Cannot convert float to int. Yes. This is expected. So we'll just get rid of all of these f's, and there we go. Wonderful. A few more of these. Okay. 0. Yep, get rid of these as well. We're currently down to no issues found. Is this going to just work? In theory, it shouldn't break. but I haven't technically tested it. Now let's do that. You may notice this is the sandbox server. I was too lazy to open the normal server rather than my sandbox server. They're literally the same. I changed nothing. Like, literally, I copied and pasted the files. It's the same thing. Okay, so let's connect to this server, and in theory, this will happen soon. In practice, it will happen in 15 to 20 minutes. Okay, that wasn't 15 to 20 minutes. Let's get logged in. Okay, null reference exception. I figured it wouldn't work right out of the box. Line 167. If tile.tiledata.terrainShape equals terrainShape.flat. So get tile position. You know what? Instead, we're going to pass in something different entirely. This will be tile data. And that's all we should need. So if data.terrainShape equals terrainShape.flat, then we adjust it. And then the tile width should be times data.x. The tile height should be times data.height plus adjust. And this should be times data.y. Excellent. Now that should work. And the cat is going nuts at the door, so while we're waiting for the encryption handshake, I'm going to utilize that time to go let her in. Oh, we've got a compiler error first, though. What do we got going on here? I don't see a compiler error. Oh. Right. Instantiate get tile position. This now just takes in our data. There we go. Okay, now I'm going to get this started up and go let the cat in. And as soon as I'm sure this is going... Oh, it did not go. Okay, that's exciting. I'm going to restart the server, because we pinged it briefly there. And now we're going to try this again. I will be right back. Never mind. It was still running. Okay. We're going to restart the server again. And we're going to run this. And yes, I hear that you want in, Ellie. I will let you in a moment. Okay. Now I'm going to go let her in. Okay, it looks like I got back just in time. I do apologize for that. She was being a cat and decided to run away instead of coming in. So she'll probably be back. Okay, so we can see here we do have some diagonal tiles working correctly. That one's not working so correctly. But our refactor appears to be reasonably functional. Fantastic. And yeah, we've definitely got some issues over here, and I'll need to logic that out and figure out why exactly that's happening. There's a good reason for it, I'm sure. But there we go. We're in largely the same position we were before, but we have more information at any given time. Now, we need to assign the neighbors. Our tile data has already been created at this point. So let's just go ahead and assign this. So if I is greater than or equal to 1, then we will also do data dot, let's see here, this is I minus 1, so it'll be to the west. Data.west is equal to our tile data I minus 1 and j. Okay. And we'll also do data.west. Actually, you know what? We don't need to do that. Yeah. Let's do this a little differently. Let's not do this here. Let's go ahead and set our data, add tile data neighbors. Let's do it like this. So data.west is equivalent to tile data ij. Now obviously that's just going to give it itself for right now. We'll come back to that. Data.north is equal to the same, and I'm just actually going to copy this section here. Data.south, data.east, data.northeast, data.northwest, and I don't need to type that out, data.southeast, and data.southwest. Okay. Now realistically, we could split this off into its own function. And I think I'll do that. Let's see, we have a neighbors section, right? I'm pretty sure we have a neighbors region. Assign neighbor, I guess. We'll do public void assign data neighbors. And what are we going to take in here? We're going to take in our tile data. We're going to take in our int x and our int y. Okay. So we're going to come up here and grab this information, which is way up here. Maybe not this way. Was it this way? It was this way. Okay. So we're going to cut that, and we're going to do assign data neighbors, and we're going to pass in our data, we're going to pass in our I and our j. Excellent. Realistically, I should probably rename these to be consistently x and y, but I'm too lazy to do that right now. So we're going to come down to our neighbor function. Excellent. And we're going to... No, I don't want to build this. No, seriously, I don't want to build this. I just want to paste this in. So, it's going to be this. We're also going to need our data map. Okay, yeah. Tile data 2D array, and this will be our tile data. And then our singular data, our data point that we're working with. And then our x and y position. Realistically, we can grab the x and y position from the data. Data.x, data.y. Okay. We'll copy those, and we'll just paste these right here to get rid of that compiler error. Excellent. And now for our directions here. I'm going to make a space right here. Okay. And we're going to have this be, let's see here, for west, x minus 1, j, or rather y. And I'm just going to do this for all of these just so that I have a bit of a reference here. This one is north, so this is x, y plus 1. South is, of course, x, y minus 1. This is x plus 1, y. Northeast is, let's see here, north and east, so x plus 1, y plus 1. This one, northwest, is x minus 1, y plus 1. Southeast is x plus 1, y minus 1. And southwest is x minus 1, y minus 1. Okay, so we'll do data.x, mathf.map min, the minimum number of data.x minus 1 and 0. And then we'll take data.y. Wonderful. That gets us either the west tile on the map or ourselves in that slot. Wonderful. So for north, we'll do mathf. Or actually, this should be mathf.max, not min. There we go. This one should be mathf.min of data.y plus 1 and map size y minus 1. Excellent. And then our south neighbor here will be data.x and mathf. With a capital M, mathf.max of 0 and data y. Minus 1, of course. Excellent. And then this would be mathf.min of data.x plus 1 and map size x minus 1. Excellent. And now for the other directions here. So this will be mathf.min of data.x plus 1 and map size x minus 1. And then this one would be mathf.min of data.y plus 1 and map size y minus 1. Excellent. And then this one would be mathf.max of data.x minus 1 and 0. And then mathf.min of data.y plus 1 and map size y minus 1. Wonderful. And then this one would be mathf.min of data.x plus 1 I just thought of something. I could have made this much easier on myself. This is basically done anyway. Data.x plus 1, and then map size x. You know what? Let's do it the easier way. Okay, so the easier way is int min x equals data.x minus 1. So essentially the minimum x would be the... or actually minus x. Data.x minus 1. So we're going to do mathf.x or .max of this and 0. Int plus x equals mathf. This doesn't need to be, well, it could be either math or mathf. I don't think it matters. .max data.x plus 1 and map size x minus 1. Okay, int minus y equals mathf.max of data.y minus 1 and 0. And then int plus y equals mathf.max of data.y minus 1, or no, plus 1, map size y minus 1. Okay, so that will just save us some typing that I've mostly already done. So this is mathf.max, so this is minus x. And then in north, we would be going plus y. And then in south, we would be going minus y. And then in east, we'd be going minus x. Or no, plus x. Okay. In northeast, we will be going plus x and plus y. In northwest, we are going to be going minus x and plus y. And then down here, we are, of course, going to be going... This is plus x and minus y. And then down here, we are going to be going minus x, and minus y. Look at how much easier that is. I was making it harder on myself than it needed to be. Okay, so that assigns us our data neighbors. Wonderful. So we now know what all of our data neighbors are without having to really look it up, which allows us to do a second pass in get tile here. Although we're currently, let's see, that would be generate terrain data there. Let's go ahead and minimize substantial regions of this. That is to say, these regions here. Just so we don't have to scroll past all of it. Okay. So, we get our neighbors there. Yeah, we need to have that for our terrain data regardless. So we need to have our neighbors on the map height. Assign data neighbors, of course, takes in tile data and data now. So we'll take in tile data and data. Wonderful. So we don't really utilize these neighbors right now. And they aren't all assigned by the time we call get tile. By the time we are through here, they're all assigned. Okay. Well, I think let's just make sure that this works as is. I'm not too concerned about it being a little bit broken because we're doing refactoring right now. And we'll probably go into a second pass on this. Well, we're already doing 2 passes, right? Well, we're kind of doing 3, but we'll do this a little bit better now that we have access to all of this information starting in the next episode. So we'll just log in, make sure nothing is horrendously broken. Okay, so something is horrendously broken. Index was outside of the bounds of the array. Data.x and plus y. Right. These need to be min. Okay. Let's try that again and make sure that nothing is horrendously broken. In theory, it should not be horrendously broken, but it probably is. No, I don't think it is. I think we're currently basically at the state we were before, but with added messy diagonals. Which isn't necessarily an upgrade, but we're set up in a much better way now. Oh yeah, that's not bad at all. This should really be an inside corner here. This probably shouldn't be a diagonal, but I think I get why it's happening the way it is. But you can see over here the diagonals are doing a pretty decent job in the places where they're supposed to be spawning anyway. And yeah, this is definitely progress. You'll notice we've got some weirdness to be sure, and that is stuff that we can tackle now that we have more information on the data of each tile. For now, though, I'm going to go ahead and put a cut in here, and you can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time when we will start using this data that we're now collecting. See you all then.